In this section of notes, we are going to take notes on exponent properties. So what I'm going to do for this lesson is, or for this note section, we're going to be writing on the right and left hand side. So on the right hand side, I'm going to list the general exponent properties, and on the left hand side, I'm going to give you examples for each of them. So I'm going to go one by one through each of them, that way you can see. So I'm going to scroll as necessary as well. But so the screen's going to stay kind of small this way, but we're going to be looking at, again, the specific property, and then we're going to look at an example of each. So the first exponent property, you've learned all of these before. Maybe there's two of them that you haven't seen in the past, but our focus is going to be the fact that these are equations. So they go both ways. So if I give you a to the m times a to the n, when I'm multiplying and bases are the same, we add exponents. Okay, so that's a property that you've done in the past. So the example, the typical example that you'd go with this one, so our first property, would be, for instance, 10 squared times 10 cubed. Well, you know that is just 10 to the 2 plus 3 powers, so 10 to the 5th. But the part that I need you now to be able to take from here is going backwards with it. This property is an equation, so the left side equals the right side, but the right side has to equal the left side. So the other example that I'm going to show you is 2 to the x plus 5. So if in my exponent I'm adding, that is equivalent, so that's this side here, that is equivalent to separating them out, 2 to the x times 2 to the 5th. Because then we can simplify that, and that's, so 2 to the 5th is 32. That's equivalent to 32 times 2 to the x power. And then we'll be able to do some other math with it from there. So again, trying to get you guys to start thinking both directions, left to right and right to left. So the second property that we're going to look at is a to the m divided by a to the n. So when I'm dividing and bases are the same, we subtract the exponents. So our example would be 2 to the 5th over 2 cubed. Well, that's equivalent to 2 to the 5 minus 3, or 2 squared, which of course we know is 4. Okay, so that's the traditional way you'd look at it. Now looking at it vice versa, we will look at it as 2 to the 3 minus x. Well, that's equivalent to 2 cubed, since it's minus, that's being divided by 2 to the x power, which that then becomes 8 over 2 to the x. Third property. Our third property is a to the m all to the n power. This one often gets confused with 1. So power to a power, we multiply. So that's a to the mn. And I can give you examples as to why each of these work. If you don't remember why they work, please reach out and let me know. I can always show you longhand why they work as well. So, and hopefully you did that when you were in Algebra 1 when you were first learning these. So this would be a problem like 3 to the 4th, that whole quantity squared. So power to power we multiply, so it would be 3 to the 8th. Vice versa on this would be 3 to the 2x. So that's a product in my exponent, so that's like right here. That is equivalent to 3 squared, that whole thing to the x, which is equivalent to 9 to the x. Next one. AB to the n. So a product is being taken to a power. Well, that's equivalent to a to the n, b to the n. Please note the operation here is multiplication. Sometimes people make up their own exponent properties. So the example for that, a very typical example would be 2x cubed. Well, that's equivalent to 2 cubed x cubed, which of course is 8x cubed. Going backwards on it, if I have 3 to the 4th times 2 to the 4th, so here my exponents are the same and I'm multiplying. So exponents are the same, multiplying them. That is equivalent to taking 3 times 2 and that whole thing to the 4th, which of course would be 6 to the 4th. We also have one for division that's similar for number 4 here. So property 5 is division, so a divided by b to the n. That's equivalent to a to the n over b to the n. And then The example for that one, the typical example would be like 2/3 squared. That's equivalent to 2 squared over 3 squared, which therefore becomes 4/9. Vice versa, if I gave you 8 squared over 4 squared, so they both have, again, the same exponent, and I'm dividing, that is equivalent to 8 divided by 4, and then squaring that whole thing. Again, that's because those exponents are the same, which would then be 2 squared, so that would become 4. Property 6, a to the 0 is 1. Anything to the 0 power is 1, provided a doesn't equal 0. I should have a stipulation up here too, b cannot be 0 in number 5. So again, anything to the 0 is 1, provided that anything is not 0. So I can take 1,000 to the 0 power and I get 1 out. Seventh property. This one might be new. I'm not sure if you've learned this in the past. So some of you will have and some of you will not have. It just completely depends. So we're going to do this one, and then hopefully these types of problems will make more sense to you. So a to the negative n is equivalent to 1 over a to the n power. 1 over a to the n power. So a negative exponent takes the base in the exponent and pushes it to the denominator. Or if it's in the denominator, it pushes it up to the numerator. So our property here for 7 would be 2 to the negative third is the same thing as 1 over 2 cubed, which would then become 1/8. Vice versa, 1 over x cubed, that's equivalent to x to the negative third. So that's going vice versa on it. So if it was in the bottom, if you want to move it up to the top, again, just give it a negative exponent. And then the last one deals with roots. So if I'm taking a root, it's the same thing as taking the reciprocal power. So the nth root of a is equivalent to a to the 1 over n. So a few of you have asked me about, like, how do I take a 4th root? How do I take a 5th root, etc.? It's just taking it to the fractional exponent. So it's taking it to the reciprocal exponent. So if I gave you 16 to the 1/2 power, that's exactly the same thing as the square root of 16. That's 4. Or if I give you the cubed root of 8, then all you have to do is into your calculator, you can type 8 to the 1/3 power. And you know either one of these, the cubed root of 8 is just 2. But that's how you can go vice versa with that one. Okay, so those are the general 8 exponent properties that we'll be focusing on, and you're going to see a lot of these problems in your review preview.